In this lesson, we're going to talk about solving exponential equations. So just a few quick reminders dealing with exponents. So remember, if you have 2 to the power of negative 2, that's the same as 1 over 2 to the power 2, or 1 over 4. Similarly, if you have a fraction, so 1/2 to the power of negative 2, again, we can take its reciprocal and then change it to a positive exponent, so that would be equal to 4. When we have fractional exponents, 2 over 3, for example, we can rewrite these as roots. So the denominator of the fraction becomes the index of the root, and the numerator goes inside with the base. So here we get 8 squared, which is 64, and then the third root of 64, which is 4. Similarly, if we combine a negative exponent and a fractional exponent, we can still rewrite this as the third root of 27 to the power of 4, but in the denominator. And then remember, in terms of the order here I chose to do the third root of 27 first, and then raise it to the power of 4. I could have done the same thing here and done the third root of 8, which is 2, and then raised it to the power 2 to get 4. So the order doesn't matter. And here, again, we've got a fractional exponent, so the fifth root of 32 to the power of 3. Well, the fifth root of 32 is 2, to the power of 3 is 8. So don't forget those rules, especially with negatives and fractions in the exponents. So when you're solving an exponential equation, the key is that you want both sides to have the same base. So for example, here, 4 to the power of x is equal to 64. Well, we want to know 4 to the power of x. So if we rewrite 64 as 4 to the power of 3, we know that x would be equal to 3. Over here, we have got 4 equals 8 to the power of x. So what I've done is I've rewritten both of these as powers of 2, or bases of 2. So on the left side, 4 is 2 to the power of 2. And on the right side, 8 is 2 to the power of 3. And that's also to the power of x, so 2 to the power of 3x. Once the bases match, then you can just set this exponent equal to this exponent. So 2 equals 3x. Because if 2 to the power of 2 has to equal 2 to the power of 3x, it means those exponents must equal each other. From there, you can just solve for x. So divide by 3, and x would be 2/3. Same thing over here. I've got 3 to the power of 4x plus 1, and 27 to the power of 2x. So I've chosen to write 27 as 3 to the power of 3. Remember, these will multiply, these exponents. Now that the bases match, I can just set the exponents equal to one another. So 4x plus 1 equals 6x. That means 1 equals 2x, and x is equal to 1/2. So your goal is always to get the bases to match. Once the bases match, you just equate the exponents. On the bottom here, we've got a few different bases to work with. So we have 3 to the power of x times 27 equals 81 to the power of 2x plus 1. All of these numbers are perfect cubes. So I'm going to rewrite all of them in terms of base 3. So 3 to the power of x, 3 to the power of 3, and 3 to the power of 4 times 2x plus 1. Remember your exponent laws. When you're multiplying two bases, we add the powers. So here, this becomes 3 to the power of x plus 3. And on the left side, the right side, I haven't changed anything. Now that these both have base 3, I'm just going to equate their exponents. So x plus 3 equals 8x plus 4. And then I solve. This last question, we've got 4 to the power of x plus 1 equals 2 to the power of x times root 2. So again, these are all perfect squares, so I'm going to write them all, these can all be rewritten as a base of 2. So 4 is 2 to the power of 2 times x plus 1. 2 to the power of x, and I'm going to rewrite this square root. Remember, this has an index of 2 and a power of 1, so it can be rewritten as a half. So here we've got 2 times x plus 1, and here we would have x plus a half with our exponent laws. Set these equal to each other, and when you solve for x, you get x is equal to negative 3 over 2. A couple more examples on the next page. The thing to remember is that 2 times 3 to the x is not equal to 6 to the power of x. So remember, because of our order of operations, this is not equal to 6 to the x. So we can't just split up the base into something like this. So this first example is a good example of that. We might be tempted to try to do here 8 to the power of x over 2, but that's not equal to 8 to the power of x over 2. So instead of combining 2 and 4, we need to split up this 8. Negative 8 is negative 2 to the power of 3. And then here we've got 2. 4 can be written as 2 to the power of 2 times x over 2. And then over here, when we simplify, we multiply these exponents. We get negative 2 to the power of 5. And here, 2 times 2 to the power of 2x. But what you'll notice is because on the left side this is negative, these bases are not the same, which means we have no solution. So there is no solution for this problem because even though the bases look almost the same, that negative changes them. And if we look at example G, we've got 2 times 1 over 3 x minus 1, and then equals to 162. What I'm going to do in this scenario, instead of trying to multiply the 2 into here, is if you just divide the other side by 2, you get 1 over 3 to the power of x minus 1 equals 81. And then we can get rid of this exponent being, this being in the denominator by making the exponent negative. So we bring it to the top and make the exponent negative. So we get 3 to the power of negative x minus 1 equals 3 to the power of 4, which is 81. And then we've got the same base, we just equate the exponents. Be careful with distributing this negative through. We get negative x plus 1 equals 4, so x is equal to negative 3. In example 2, you're being asked to simplify. So this is just a reminder of some of your exponent laws again. So here, 3 to the power of 2 to the power of 3 over 2, we're multiplying. So we're multiplying the exponents because we have a power to a power, and essentially the 2's cancel each other out. So this is the same as 3 to the power of 3, which is 27. Over here, again, we're just using our exponent laws. So we have the square root of 16, which is 4 to the power of 3, which is 64. And in example 3, these ones, we've got x to the power of 2/3 equals 4. So here, what I've done is I rewrote x to the power of 2/3 as the third root of x squared. And then what I did to try and get x all by itself is I square rooted both sides so that this squared and this square root cancel out, and we're left with the third root of x equals 2. And then you can cube the other side, right? If you cube both sides, this and this would cancel, and we cube that side, we're left with x is equal to 8. So just a little bit of simplification and opposite operations to try and solve for x. Similarly, over here, we have the third root of x to the power of 4. So the first thing I did was take the fourth root of both sides in order to cancel out this power of 4. And you're left with the third root of x is equal to 5. And then if you cube this, you get that x is equal to 125. So that's how to solve exponential equations.